Good day, everybody. How are you all doing? Hope you are doing great today. This is Dr. Nandi. For those of you who do not know me, I frequently go live on my channel and I solve problems in math, all kinds of math, statistics. I lecture on statistics, and I have solved a lot of math problems in my YouTube channel. So please take a look into my YouTube channel. If you like my videos, give me a thumbs up, and please subscribe to my channel by hitting the red subscribe button. So today we are going to solve a linear regression problem. So says the number of heart transplants in the USA is given by this data. Year from 1 to 10, and numbers of heart transplant from 2193 all the way to 2804. First question asks, find the least square regression line to predict the number of heart transplants from the number of years. Okay. I will also add a question. How much is the increase in heart transplants if there is a 2-year increase, if there is a 2-year increase, there is a 2-year increase in time. So first we have to find the linear regression equation between x, which is number of years, and y, which is number of heart transplant. That is the first question. Okay, so we will use the TI-84 calculator. I prefer to use the TI-84 calculator. The first thing I will do is clear the memories of the calculator. I do it by second button, then the plus button on the bottom right corner, then number 4. Second button on the top left, plus on the top right, and then number 4. Okay. And I get clear all this on my calculator screen. I hit enter, done. Then I will press the start button and number 1, which is edit. Now I will enter X data in L1 and Y data in L2. So first I will start with the X data in L1, list 1. Okay, so X are the number of years. It is the independent variable. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Once I'm done with the number of years, my cursor is now sitting on line 11 in list 1. Hence, it is showing at the bottom left corner of the calculator L1 parenthesis 11. I need to move it to the first line in L2. I will do it by pressing the right cursor key on the top right corner. Press the right cursor key to move the cursor from line 11 in L1 to the first line in L2. Now it is sitting on the first line in L2, where I will enter the corresponding Y, the dependent variable. Remember, the heart transplant numbers depend on the years, so it is Y. So I'm entering the numbers, Y numbers in L2, 2193, 2209, 2163, 2211, 2232, 2332, 2278, 2531, 2656, and 2804. So I have entered the X data in L1 and the corresponding Y data in L2. Now I am ready to find the least square regression line. Remember, it will be an equation of Y, which is the dependent variable which depends on X. Okay, so to get the least square regression line, I will press the start button. Then I will highlight the calc on the top row. then I will press number 4, which is 1. So stat calc, then number 4, which is lin reg ax plus b. Lin means linear regression ax plus b. Okay, so my x list is L1, already I have done it. Y list is L2. I go all the way down to calculate. So I'm going all the way down to calculate by down cursor key on the top right corner and hit enter. So my least square regression line, this is given by y hat, although the calculator just gives y. Y hat, this is called y hat because this is predicted y. That is the value that is forecasted from the given x values. Predicted y is equal to, so my slope is 65.27 x and my intercept is 2021.93. So this is the least square regression line equation. Least square regression line equation. Least square regression line equation. Okay. Predict heart transplant for year 9. So part B, they're saying what is the predicted y, what is the forecast y for x equal to 9. So I take the x value of 9 and substitute in the least square regression line. So it will be y hat equal to 65.27 times 9 times I give by dot plus 22021.93, and that is equal to 65.27 times 9 plus 2021.93, and the answer is 2609.36, which we can round off to 2610. So in year 9, the predicted number of heart transplants, this is the predicted number of heart transplant in year 9. Okay, then they ask us in part C, what is the residual for year 9? So residual is the error between the actual and the forecasted value or predicted value, is y actual minus y hat. So my actual I get off from the table, year 9 is 2656 minus 2610, and that is my error. Notice in this case the actual value of y is 2656, number of heart transplants, whereas my equation, least square regression line, is predicting 2610. So the actual point 2656 is above the predicted value. Now the predicted value is sitting on the regression line. So here the residual, because the actual value is greater, is positive 46. Okay. Now they're asking interpret the value of r and r square. For that I will again press stat value, stat, then highlight means move the cursor to on the top line by the right cursor key to calc, and then number 4, lin reg ax plus b, and I go down to calculate and hit enter, and along with the equation I get the r square value. R square is called coefficient of determination. Coefficient of determination. And only for r square we are going to multiply by 100%, coefficient of determination. And that is r square in this case is 78.2% approximately. 0.782 in the calculator, I multiplied it by 100, or 78.2% of the variation in y can be explained by the linear regression equation. Linear regression equation. Okay. Then we also get a value of r. Notice here the slope is positive, 65.27. Okay. So the r value, r is the correlation coefficient, is also positive. R is your correlation coefficient, and that value is r is 0. Let me write r is correlation coefficient is 0.884, which indicates strong positive linear correlation. Strong. Why it is strong? Because r value is greater than 0.7. Strong linear correlation between x and y. Linear is important because we are fitting a line, and because r is greater than 0.7, it's a strong linear correlation. Now the question is, how much is the increase in heart transplant numbers if there is a 2-year increase in time? Part E. Now we know the slope, 65, 65.27, maybe rounded to 66, rounded, is number is slope, number of increase in heart transplant every year, increase in heart transplant every year, transplant every year, in 1 year you might say. That is the definition of slope. How much y, in this case number of heart transplant, changes if x increases by 1 unit. So if your time increases by 1 year, your heart transplant increases by 66. So thus the question asks for by how much number of heart transplants will increase. In 2 years, heart transplants will increase. Heart transplants will increase by twice that amount, will increase by 66, because 66 is the increase in heart transplant in 1 year. In 2 years it will be double of that. 66 times 2, which is 132. So the last part answer is 132 is the increase in heart transplant in 2 years. How did I get it? Slope multiplied by 2. What is the slope? In 1 year it increases by 66 heart transplant. In 2 years it will be twice that amount, which is 132. 66 multiplied by 2, 66 is the slope. Increase in heart transplant in 1 year. So increase in heart transplant in 2 years will be twice the slope. 2 times 66, which is 132. So I'll stop here. I gave you a brief flavor of what you can expect in linear regression problems. First you have to fit a line between x and y. Then you look for the slope, which is the coefficient of x in the equation, and the intercept is the other number. Now the slope means how much x is increasing, how much y is increasing per unit increase in x. Here x is time. So with increase, if time increases by 1 year, slope gives the number of heart transplant increase in 1 year, which is 66. So in 2 years is 2 times 66, or 132. Then we use the equation to predict the number of heart transplants at year 9. So we plug in x equal to 9 in the equation, and we predicted or forecasted 2610, which is lower than the actual value, 2656. Hence the residual or error, which is y actual minus y predicted, is 46. R gives us the strength of the linear relationship between x and y. In this case, R came out as 0.884. Anything greater than 0.7 is a strong positive linear correlation between x and y. Also, we have R square, which is coefficient of determination. Here it is 78.2%. Only for R square, we take the value from the calculator, multiplied by 100%. In this case, it was 0.782, multiplied it by 100%, shifted the decimal 2 places to the right, or 78.2% of the variation in Y, in this case, heart transplant numbers, can be explained by the least square regression line equation. So I'll stop here today. In case you have any question, please do not hesitate to shoot me a question, and I will reply to each and every question that you ask me. If you like this video, please give me a thumbs up. I really appreciate that. If you like this video, share with your friends, and please subscribe to my channel by hitting the red subscribe button at the bottom right corner, and at the same time please click on the bell button, which will send you a reminder every time I upload a new video. So please do not forget to watch me tomorrow when I'll upload a new video, and I appreciate the fact that you took time to watch my presentation. Thanks for watching my presentation. Take care, have a nice day, and I will see you next time. Take care. Okay, bye.